A very good evening to everyone. Welcome to the free workshop on the theme Well Test Interpretation by Mr. Venkata Vijay Sankar Anuprakas. He is Assistant Professor in Department of Petroleum Engineering at Aditya Engineering College, MS Oil and Gas from the Robert Gordon University. His specialty is numerical simulation using IMAX like Eclipse, IMAX CMG, and fast wheel test, etc. Coming to the workshop, first we'll discuss about the introduction to well test, then types of well test, then importance of well test at different stages of field development. At this time, I would like to tell that there will be an open Q&A session where you can post your question in the chat box. Now, without wasting time, I would like Mr. Venkat Vijay Nambaka sir to start the session. Thank you, sir. We can start. Sir, you can just unmute yourself. Yes, sir.
Yeah, thank you, Nikhil, and thank you, Petroleum Engineering Association, for giving me such a wonderful opportunity to share my knowledge on the area of well test interpretation, and also the participants who are taking some time out of them for participating in this workshop. I hope by end of this session you will have some like add on to the already existing knowledge in the well test. So before going to the session, so this is the objectives of our session in today's well test interpretation workshop. So first, as I told, it is talking about introduction. So by the end of this workshop, you will be able to identify what is the list of major types of well test and what is the principal goal of each type. The next is what are the major tasks of a well test interpretation. There are certain three classes of interpretation, well test interpretation there. We in the coming time we'll be discussing about that. And in the last point is about the define. You will be able to define and give the typical values for each of the primary variables which are used in the well test interpretation. The next is the task is about the types of well tests. So at the end of the session, you will be able to identify what is the identified the test and applied for different tests. What are the parameters that can be obtained from this test? All this. So coming to the last part of this session, that will be on what is the importance of this well test at different stages of field development. So before well test interpretation, let me show you one. There are two pictures on this presentation. One is talking about a doctor who is analyzing the what you call the brain, right? This is like doctor can physically observe. See, there is a undergoing possible in that. So unlike the other branches where you can observe physically, this you can't get it physically. So we are going by indirect ways. One of the indirect way you might have learned that is about the well logging. Well logging is also a indirect way of obtaining the data, but this is a static type. But under the flowing condition, is there any test to indirectly get information regarding the reservoir? Yes, that test is nothing but your well test. So when you compare it with other engineering, like we can't go on the, we can specify a design and go by that. So we don't have any complete that we have to follow strict rule. It all depends upon what is the availability of the geological formation. The next is when you compare like engine which is designed by engineer, mechanical engineer, or a building or anything related to a structural engineer, you can define a model. But here in the oil and gas sector, it is like uncertainty is involved. So because of that, we need to rely on this well test. The next is, as I told about, the system is not physically accessible. Unlike the other branches of engineering where you can completely rely by going into physically accessible, but this is not physically accessible. So that is why we need to have an indirect measurements to determine the properties of the system. What type of properties, like we'll go ahead in the presentation. I'll discuss about what are the properties we'll be discussing. This is a similarity, like when you take about this well test, it is similar to the water, finding out the water wells. Like where also there are some tests to know whether the water is existing in the reservoir or not. So this can be have a similarity between these two. Next, a special case of determination, indirect determination of reservoir properties, that here flow rate and the pressure drawdown of a well producing under stable condition, and this can be calculated by permeability. Right, in the well test, we are concerned with the pressure, flow rate, and both as a function of time. Only these three will play a magic. Go on to the next this. What is this is, with respect to time, you are recording it. You are recording the pressure as well as the flow rate. So if you take the other than the well test, we have so many other ways by which we can get to get permeability K, skin factor, and so on. But at certain time, you can only get a one value at a time. But here, by using the well test, we can get the things simultaneously one after the other. That is the beauty of well test. So what does a well test assume? So this point you have to make a note. This well test always assume that is producing oil at a constant rate. It may be a gas as well, but always it will be measured at a constant rate. If you observe the diagram here, this is talking about the flow rate from point at 0, let it be some time t, up to 0 to t at the start of your well test to your time up to which you are considering. You are observing that it is following a parallel line to your x-axis. What does that mean? So this means that it is a constant rate, or in terms sometimes called as constant terminal rate. So as I told about doctor, how he will be taking the breathing is one, the other one is a pulse. Basing upon that, he will say that okay, you are good, your health is not good. So similarly, in the well test also, we have as different things we can obtain, extract it from this, only these two values. So how do you get these values? Pressure as well as the flow rate. So here what we are doing is we are maintaining the constant rate and at which we are obtaining the pressure response. There is also other way in which we will make a constant pressure at which you will have a variable flow rate. But this type of phenomena where we are applying this constant pressure and a variable flow rate, it is a water influx. But since we are talking about a well test, we are not concerned about this value. The next is the bottom hole pressure of the well will decrease as the production begins and will increase when the well is shut in. So imagine that this is your well and above which you are having a tree, and this is your formation from where you are producing it, right? So they are talking about the bottom hole pressure. So bottom hole pressure is this, again is the formation, a pressure will be acting, that is the bottom hole pressure, and it is not always equal to your reservoir pressure. It is always less than your, this initial pressure is always greater than your bottom hole pressure. Because if this condition doesn't exist, the fluid will not flow into your wellbore. So that is why we have to make sure that this is always in this relation. Now, how the pressure changes as a function of properties of the reservoir system. So if you see here, the curvature at which it is from constant rate, the pressure is declining with respect to time. Whereas at this point, there is no flow rate. So this region, whatever you are talking, it is called drawdown, because your pressure response is getting dropped from this point to this point. Now what happens when you shut off the well or shut in the well? So initially it is continuously producing it is continuously producing to the surface. All of a sudden you close the well at the surface. What will happen is, you'll observe that till this fluid is filled in this region, it will show you some response. Because of that, you'll see that there are some changes in the well, and that is called well bore storage. So that is why you don't see the well bore storage, we don't see the well bore storage factor in the drawdown test. And what is this test? This is under the shut-in condition, we are measuring it, and this is called build-up test. So disturbing the reservoir by changing the flow rate of a well and observing the resulting pressure change is a noisy experiment, so by which we can observe the dynamic reservoir properties indirectly. So what are the three main important things that we can obtain, record it? That is your pressure, flow rate and time. But pressure and pressure and flow rate is measured with respect to your time. So changing the rate and measuring the pressure in the same well bore, so when you are doing it, that is called single well test. We are observing that within the same well we are doing it. So that is called a single well test. The change in pressure at an offset well because of the rate of change. So offset well is like you have well here and you have some other well somewhere here at a distance. Maybe this is a nearer or sometimes a far. So changing the pressure at this offset well, we are observing what is the change in rate in this well. So change in pressure in offset well is smaller than the active well. Obviously, because the place where we are exactly doing our well test, it will have some influence if they are directly connected to your through your reservoir. So what will happen is during this there is a time lag, because soon after you produce something, it will take some time to get influence on the other well. So that is called a time lag. What is the time lag is? Like suppose I am presently giving the webinar from your India. If you take a point of time which is ahead, I mean which is far behind your Indian time, then we'll call it as a lag in time. That is called jet lag. But here time lag is also the same thing. We are seeing the time lag because the response is not immediate. It is taking some time. So changing the flow rate in a well and measuring the pressure response in another well is called multiple tests. Anyway, don't worry, we'll be going in detail and just giving what are the things we can get from your well test. So what is this transient? Nowadays they are not referring it as a well testing, or they are calling as a transient testing. So of course the technology is same. Even this include, what is the difference between the transient test and your well test is, it also includes the declining curve analysis. Both will give you some impact about your reservoir. So why can't we name it as a new term that is called a transient testing? So this involves the measuring the change in flow rate. So when you talk about the change in flow rate, delta Q, due to the pressure changes or changes in flow rate of individual layer as a result of change in the total flow rate of the well. See, because of maintaining this, we are getting this response. So here in this well testing, we need to check it from the point of view of flow rate only. So, but when you're talking about the water influx, we'll talk about that, keeping a pressure as constant. But here we are concerned with only constant flow rate or constant terminal rate. So in a reservoir is a transient state when the pressure or the saturation of the fluids are changing with respect to time. So the pressures, whatever you are talking about with respect to time, it is changing. Or even the saturation of the fluids which are changing with respect to time, and the rate of change is different at different location. So let me give you a plot of this, so which is indicating the time, pressure, and the above plot will be your Q and time again. So as I told that all the well tests will be done at a constant terminal rate or constant rate. So at this constant rate, obviously it will show some response in the pressure, and that will be in a declining trend. Because when you are producing, suppose you take a bottle which is full of water, slowly you are feeling thirsty. So you are taking some water again and again. So initially it was full. After a certain time, what will happen? This will become empty. But reservoir, whatever you are talking about, it is such a large. So you can't remove it immediately, but obviously in the long run, here it may be taking like 20 minutes or 30 minutes. You'll be completing this water bottle. But In the case of reservoir, it is so large that so this will be continuously declining but never reach the pressure 0. So this whatever you are observing, that is your pressure is declining in this order. So why I am making the correction in this? Because as long as it is maintained at a constant, then only the response from this record is in the declining order. See how beautiful it is. Like always we'll be getting only pressure and flow rate. Now the question will be, from where we'll be getting this? So we are having the gauges. What gauges we are having? Pressure gauges and flow meters or gauges. And this, since it is measured with respect to time, we will also have a time recorder. What previously they used to have is, they simply used to lower the, during the well test, they used to have the gauges placed in the your well bore, and the corresponding things are marked on a paper. There is like a cylindrical paper wrapped on your inside of the barrel. So with respect to this reading, right, this is a cylindrical wrap. So when you open the wrap, it will be like this one. So when you see that this reading will be marked, so that even though I am showing it as a continuous decline, you will never get a declining of such rate, like your pressure response will be like this. So with respect to your pressure and time, this will be the response. But how you are getting into this picture? So we are doing a filtering. We are not taking all the points. Suppose we are having for a period of some number of days, we are getting around 2000 or 20,000 points of data is available. But out of this, we are not taking all the 20,000. We are maybe taking around only 2,000 only. Because if you take more data, that is good, but depending on the test, so we should always take, we should not always take this only 2,000 points. Always we should take a higher end than this actual required, such that in future if you want to analyze this, we can filter. So in this gauges, in this particular thing, the pressure gauges accuracy is okay because the crystal like quad gauges are used, but whereas the flow is not always, some errors are there always when you are measuring the flow rate. Since we are in well test, we are concerned with the pressures because we are getting indirectly certain parameters. Now, coming to the next point, as I told that monitoring the flow rate and pressure. So because if flow rate is maintained constantly, okay, pressure is also declining, it is okay, but all of a sudden there is some spike or anything, or there is some sudden drop, so then we have to be very careful. So we should check what is the reason for that. So that is why monitoring the flow rate and pressure while reservoir is in the transient state. So now, what do you mean by this transient state? So there are regions: early region, middle region, and late. So when you talk about this at a constant flow rate or constant rate, we'll call that as a transient. Why it is called a transient? Suppose you are taking the flow rate Q1, at which we'll be getting a pressure response of this kind. Suppose it is not a Q1, it was changed to Q2. Then again the pressure response for the Q2 will be, the response will be entirely different. So each one of this, for with respect to your flow rate, will be getting one transient. So the transient state here means the rate at which we are taking at a constant flow rate, will be getting one reading. Next. So from that information, we can get properties of the reservoir system. Now, coming to the next one, well testing is an inverse problem. What is this inverse problem is? You will have input, you will have output. We don't know how it was transformed into this. What is input? Your flow rate is your input, and the pressure response is your output. Your input is your flow rate, and the output is your pressure response. So in between this, it should have passed through certain model such that you are getting a output. Suppose you know the input, we don't know the input, but we know the model and we know the output. So that is the case of your inverse problem. So well testing is an inverse problem, that is the system input and the system output are known and the properties of the system are to be determined. So this system through which it is passing, that is not known, that is unknown. So that is why it is called a inverse problem. So of course there are other sources by which we can get other than the well testing, which includes wireline formation testing or gauges or rate transient analysis, log derived permeability estimates, and core analysis. But the problem with this is all these tests are limited to only early time region only. Means a near wellbore region we can get the information regarding the near wellbore region by one of these measurements or the data from this. So what is the core analysis? Like we'll be having a cutting of your core. It may be of a horizontal orientation or a vertical orientation. So from where also we can get a permeability. But the other source from where we can get the permeability is through your well test. So what are the two major tasks that are done in a well test interpretation? That is, one is a model identification, the other one is a parameter estimation. So model identification, like you always should select a right model, and if you don't select the right model, obviously your value or the parameter, whatever you got, will not be getting a right information. So even if you don't know why we have selected that particular model, even that is also meaningless of doing a well test interpretation. So what are the parameters estimation, like a well test parameters estimation? Like as I told, one method is like fitting a straight line into these three regions, particularly the, yes, someone has a doubt? Hello?
Sir, if they have doubt, they can put in the chat box, sir. We will take at last.
Okay. Okay.
Okay, sir.
So one method is like we can divide this into early region, middle region, and late region. So when you take about the straight line method, we are fitting a line into our curve of pressure and time. So similarly, what are these type curves? Type curves are these are pre-calculated curves which are generally in terms of your dimensionless variables. What are these dimension variables are? Like a pressure response, which is in terms of PD, TD, and RD. What is this? RD is the radius of distance with respect to your wellbore. It may be near or it may be very far. So this type curves is a predetermined or the pre-calculated curves from where it doesn't require any particular units. You can either use in, because these are dimensionless, so you can avoid that, like avoid the problems of unit conversion in this type curves. But these are also not limited to everything. These has certain limitation, like a fracturing or afterflow analysis, where we will have a different type of type curves. What is this simulation? So whatever we are getting from this, ultimately we will putting in a reservoir model where we require permeability, and pressure, average reservoir pressure. So from where, which will be given into your simulation model. Now, what is this history matching? History matching is like you already produced the well for a certain period of time. From there, you already know what is the pressure and flow rates for that particular well. And we try to fit the future into the basing upon the past. We'll try to fit the future and we'll try to predict what is the estimate of that. That is called history matching, by the name history matching. Matching the present one with your past one. Now, what is this logarithmic scale? Comprises a late time data, such as 90% of the data fall in the last log cycle of the graph. As I told that what we are doing is we have a flow rate and a pressure with respect to time. These we are getting from the gauges. Now we are trying to fit a line or the curve into one of the regions such that we can get some information regarding the reservoir parameters. So for infinitely acting, this is one example of that. So this indicates that 90% of the data, whatever is getting, that is in the late region. This is the last one, is the late time region. This is the early, middle and late. So why? Because rest of the few data will be available here, 10% will be available within this, and most of the time it will be available at the late. So that is why if you do this normal P and T relation, we may not be getting a proper fit. So that is why we try to take it in terms of a semi-log plot, which is a popular one, and also log-log plot. Log of P and log of delta P and log of T, delta T. So why we are representing in this? Because the data which you are presenting in the P versus T is not easy to analyze. That is why we are using the other type of plots. So that is what the next point is. Relying on the single graph scale for interpretation may cause important behavior to be overlooked, so leading to invalid results. So it is like we have to continuously test it for which of the logs, which of the plots and models are going to be a best fit. And that too, we should not blindly go with one particular model. It is like hit and trial. Now, simple identification of the producer fluid to determine the reservoir deliverability and the complex features. So we can range it from your reservoir deliverability to your complex features like fractures or faults. All this we can be going into that. So what is this well test interpretation? So well test interpretation is the process of obtaining information about a reservoir through examining and analyzing the pressure transient response. If you remember, I told what is a transient response. For one particular flow rate, we'll be getting one type of response. So this is one scale. There is also other possibility of we are changing the flow rate and we are observing. This is a second curve. So this is whatever you are talking about, analyzing the pressure transient response caused by the change in the production rate. By changing the production rate, and even though I am showing it here, means up to this point the flow rate is like this. After that, suddenly we change the flow rate, obviously the curvature of this will be further changed. So it is important to note that information obtained from the well test interpretation may be a qualitative or a quantitative. It may be in the form of a numbers or it is reflecting something. So identification of the presence and nature of the no flow boundary or down dip aquifer is just as important as estimating the distance to the boundary. So we are plotting it with respect to pressure and time. At certain point, as the pulse is transferred into your reservoir, if there is any obstruction, obviously it will not give you any response. That will result in the change in the curvature of the graph. But if there is no such thing, obviously it will continue the same trend without any obstruction. So that is why the comprehensive interpretation of acquired data is critical for efficient reservoir development and management, because it quantifies the parameter that characterize the dynamic response of the reservoir. Dynamic response means with respect to your flow rate, constant terminal rate, we are getting a response, and that response is in the form of a pressure response. So what is being done in your data? Once you obtain that, so the transient test I told, for each flow rate will be having a transient, which will be following one type of a transient. So transient well tests are conducted as a series of dynamic events by specified changes in the surface flow rate. So suppose this is your well, and you are producing from somewhere here, but whatever the things you are changing the surface flow rate. We are not changing at the bottom condition. So it will take some time to give a response with respect to your reservoir. It will not be immediate. So during the interpretation, it may be desirable to enlist just one particular event or all events simultaneously. So the data must be processed accordingly. The first step of data processing is to split the entire data. Generally, this data, it will be stored like a pressure flow rate with respect to your time. So this is like you may have a number of like 20,000 or anything, depend upon the point at which you are recording it or storing it. So this entire data is data set into individual flow periods. So what we are doing is we are taking the complete data of that, and we are making all the plot, all the data on this, and we are trying to segregate the flow periods. So what is this flow period is like? This is a wellbore. This will talk about the wellbore storage, and this will talk about your middle region, and this is into your reservoir. So any response we are getting immediate means it is within your wellbore storage region only. That is this one. So it has, I'm drawing it with respect to the corresponding pressure and time. So this region, near wellbore region, initial and initial response reservoir. So these are the three regions we will be having it. That accordingly we have an early or middle or late. So the exact start and end day of the flow period are specified. Obviously, when you record it, because sampling rate is usually high, means when you take a sampling rate is more, it is indicating that you have a better accuracy. I mean, if you have more data points at this point, then you can put a right one into this curvature or the first flow period. High density of data is needed only for a early time period, because that will be characterizing the about the wellbore. So that is why if you have more points at this early time transient, that will be very good. So for that we have a different algorithms to reduce the data set to a manageable size. As I told that you have a multiple number of, it may be like for 1 minute or for a period of certain time, it has been recorded. So out of that, we are picking only chunks which are managed, which are required for us. You may have so many things, but out of that, you are picking only things which are on or falling in a particular line. Because of the nature of the pressure disturbance of propagation, so that is why we are taking a sampling is preferred. So even though we have all data, we will be picking only certain samples. So the sequence of events should incorporate the recent flow rate change during the test. So this enables the rigorous accounting for the superposition effects. Superposition effect is like, if you take one well is produced and for which we have a pressure and flow rate as a function of time which is being recorded. So after certain period of time, another well is drilled into the same reservoir, and now the flow rate is not Q1, it is changed to the Q2. Now what we'll be doing is, like, we'll be taking the pressure response of each of the wells and add up. So that effect is superposition theorem. And when you do the superposition for n number of rates, you'll understand about that. The shape of the pressure transient curve is affected by production history of the reservoir. Of course, it is like the declining curve is like this, or a very high declining rate. Depending on that, your response of the pressure will be different. So each change in the production rate generates a new, I think this point already discussed, for each change in the production rate, so that generates a new pressure transient that passes into the reservoir and merges with the previous pressure effect. Suppose like you are producing it for a certain rate up to this point, and after that it is further changed. Either it may be like increased, if it is shut in, it will increase. If it is like continuously producing, but the rates are not the same, it is Q1 to, it was changed to Q2. So for each of this, we will have a transient, pressure transient. So pressure trends observed at the wellbore results from the superposition of all pressures. So what are the other steps is, once you understand the pressure changes, the next step is, we'll try to identify what are the features it is going to reflect. So the best of that is your, even though we're taking one graph of a build-up. So if you take a normal build-up or anything, it will be like with respect to your Horner plot. So in addition to that, if you add a derivative graph, so here we have one graph which is reflecting the normal one. The other one is this one, and this is represented in a semi-log. So after the data are transformed, the task of identifying the flow begins. What is this flow regimes? Is like, is it a radial flow? Is it a radial flow or a linear flow or hemispherical or spherical? If it is a fractured bilinear, dual porosity. So there are n number of such models are there, which will also indicate which is the best suitable for the data. We, out of this, all this, we have to identify one of that which is a right fit. If you choose a wrong model at this time, obviously the further processing of using of data will give a corrupted result. So till now we have seen what is this, but how it is done is will be collect the data. So which is your pressure and the flow rate with respect to your time. Next, we have to check the quality of the data. Is it like continuously or some breakage is there or some sudden changes are there? So we have to observe that that is reflecting your quality. So what is this deconvolution? Deconvolve. Like in reality, your pressure response may be agreeing, but the flow rates may not agreed. So in this case, what will happen is we try to filter these variable rates and try to make it as a constant rate, which is originally in a variable flow rate. Now we are transforming that into a constant flow rate. For that we have a transformations. It may be of a Laplace transformation or non-linear transformation. So that all relates to your deconvolution, convolve and deconvolve. So once you are made into your desirable condition like pressure response and a constant rate, then we'll check with the what is the type of flow regime present in the test data. As I told earlier, like we have a radial, linear, like bilinear, spherical or hemispherical, cylindrical. All these are like flow regimes. Depending on the response of your pressure with respect to your derivative pressure, I mean what you call the derivative graph. As I shown you, one response is this, and the other one is so once you have selected the flow regime, the next important task is what is the reservoir model that is used for the next probable one is what is the probable reservoir model. Once you estimated this, next is to estimate the what are the parameters that characterize the model. So by fitting the straight line and log method, we are able to obtain which is a better response. I mean better fit. So after that, we have our simulation and history match where we can use. If you feel that this is a right fit, so calculate that our results are good, they are agreeing, because what do you mean by confidence results is measured and your observed. When the difference between these two is a minimum, obviously we'll have a more confidence of our model. So interpretation, they estimated the model parameters. What are these model parameters? These are permeability, skin factor, average reservoir pressure, skin factor already told, fracture length, So in certain cases, you will have a vertical and horizontal permeability as well. Some can also evaluate the porosity as well. So what is this validation of the result is? We already know what is the previous trend of this. So again, we are checking it whether it is matching or it is deviating. That will give you the validation of our result. Now, what we learned is the first part. What is the well test and what is the processing, what is the data processing that is involved in that, and how it has been responding to that. So in the next step we have seen is what is the well test interpretation, what is the procedure for well test interpretation. That started from the data. After that, the quality control, then we convolute it, then we change the regimes, select the regimes and the reservoir model, and from there we will be getting the parameters. So once you do done with that, then we'll go with the simulate or history match response. Once that is done, then we'll go with the confidence interval. I told about that. Next is a interpretation, interpret the estimate model parameters. Model parameters is like what you are assuming, whatever things we can get from that particular model. Now, coming to your types of test. So there are wide ranges of types of well test, as a number of different ways of categorizing them are also possible. So their test may be classified by the way in which they are carried out. One, it may involve one well or a multiple number of wells. So it is run by opening up a well for production or shutting a production well. Whether the well is produced or injection, obviously it will show you that at what stage we are doing it. It will result in an exploration well or a production well. Now, what are the deliverability steps? Test is the primary objective of a deliverability test are to obtain the samples, well deliverability. So determine what is the well's potential, develop the inflow performance curves, IPR, for a system analysis. Next, I told about the transient. The primary objective of a transient may include estimating the in situ permeability to oil and gas. The next is your area, drainage area. Next, evaluate the stimulation treatment, like you have done a fracturing job or some cleaning is done. What is the change in that effectiveness of the treatment? So to estimate the drainage area and fluids in place, we will use transient test. What are the multi-well test? Like more than one well is there. In a multi-well test, the rate is changed at one well. That is called active well. And the pressure response is measured at the one or more observation wells. So these are often more complex than a single well test. So that is why we usually run to quantify the degree of communication between the two wells. Suppose this is your reservoir and one is affecting the other one. You may have only two or more than two. So that will result in your what you call offset. This is your original well and the surrounding well, these will act like a offset well. So as I told about a single well test, in a single well, the rate is changed and the pressure response is measured at the well being tested. In all these cases, we are just taking only pressure flow rate as a function of time. Using the same data only, we are estimating all this. So the objective of a single well test include degree of damage or in situ combustion, even the drainage area. So is it like a near region or far region up to where it is been? So there we'll talk about radius of investigation. Is it near or far from your response? So now we are having a drawdown test. What are these drawdown tests? Drawdown tests is the reservoir is initially at a uniform pressure and the well is to be tested is shut in. So initially you will be having a pressure which is declining. Suddenly you have shut in. So after that it will try to increase to a certain level. So the well is open for production at ideally at a constant rate. The resulting pressure response is measured as the pressure draws down. What are the build-up tests? So build-up test is like a certain period we'll be producing it. After that we'll shut down the well and then again we'll try to produce. So 3 different periods we'll be having in this. One is the flowing period, the other one is a shut-in period, and again we'll be having a flowing period. So in a build-up test, the well has been producing ideally like your drawdown test, it is also like at a constant rate, thus creating a pressure gain in the reservoir. So the well is shut in and the resulting pressure response is measured as the build-up test. So what is the thing we can get from your build-up test is your wellbore behavior regarding the wellbore storage. You can get it from your build-up test. Exploration test. For a test on exploration well, the focus is on to get in the exploration. We don't have any information regarding the reservoir. What we want to do is we'll get as much details about the reservoir. So that was the objective. Objective of exploration test usually include the fluid sample, estimating the initial reservoir pressure, what you call the fluid sampling. Next, initial reservoir pressure. Why we are, is there any other way by which we can get the initial reservoir pressure? Because once the well is disturbed, it will not be getting back to its original condition. So evaluating the productivity. Next, estimating the distance. So how far it is from the your boundary. Whatever the response you are recording, you are creating a pressure pulse. Or at a constant flow rate, we are taking a continuous recording of that with a decline. So if there is any boundary, what will be the response? All of a sudden it will drop, or it will show a increase. So the development wells, well test, the focus here is on individual wells and near wellbore area. I think I already told about the early region, middle region and late region. So this development tests are to understand about the near wellbore area. So this includes about the estimating the drainage area, pressure, Evaluating the stimulation treatment, like it is been plugged because of the perforation, or it is under acid treatment. So after that we can get, we want to know what is before, what is after, by after doing this test. I mean, what they call the cleaning. So during that time we can do this development test. So we are estimating the reservoir permeability. All this we can obtain, which is really relatively inexpensive. So you have a different, till now we have seen as a generalized one, but they are classified into this pressure drawdown test and the pressure buildup, multi-rate. Multi-rate means changing the rates. Multi-rate is different from multi-well. Multi-well is a number of wells, and multi-rate is about a different flow rate, Q1, Q2, Q3, so on. So in multi-rate also we are having a two rate flow test and N rate. N rate means N such flow rates are available, or we can get it as a QN. So next, coming to your gas well. What is this gas well is? The equation or the response is entirely different in gas wells compared to your oil well. What is the difference is pressure, the gas is compressible. So whatever the equation we are going to use, we can't directly use it. So that is why we have two types of equation, two types of things are involved. One is the average pressure, the other one is a pseudo real gas pressure. But what is this flow after test is? So we are just recording the same thing as we did with your oil wells, but the response is quite different in the case of your gas wells. Sudden changes that only happens with this flow test. What is this isochronal test? As the name indicates, isochronal. Time for different same time period, will be shutting the well and observing the response. So what is the modified is? In the case of isochronal, we try to observe that it will try to regain its original condition of flow. In the case of isochronal, so you may have in such cases which is like it will be returning to your original condition. What is the modified is, it will not leave it until, declining of that is there, but we have not expected that it will be reaching the initial condition. That is the modified isochronal test. What is the injection test is? These are analogous to your drawdown and build-up. Follow-up is like a build-up, but what is the main difference is? So if you take the flow rate Q in this case, so here the injection well we are injecting the water into that. So all this data, whatever you plotted, that will be plotted with respect to negative Q, because we are injecting the fluid into the reservoir. So what is this interference and pulse testing? So interference test is like when you have a n number of wells and you are seeing what is the effect of flow rate on one on the other. To check that, we do this interference testing. What is the pulse testing is, we'll produce for a certain period of time and then again we'll close it, and this will be repeated in a series of tasks, and that is nothing but your pulse testing. So these are also there, but these are limited only to your wellbore region only. So first of that kind is your pressure build-up test. So pressure build-up tests are conducted for stabilizing a production well at some fixed rate and placing a measuring device in a well and shutting the well. So first we'll be conducting a stabilizing a producing well at some fixed rate. After that, so placing some device in that, again we'll shut in the well. So that type of thing is called, and this is the most one of the most commonly used, because this is the place where we can get the wellbore storage coefficient. If you see the adjacent curve, so we are seeing a two different branches which are coming from the actual one. One is a semi-log, the other one is a derivative plot. In derivative plot, the same instead of taking simply P, we'll be taking as a T dP upon dt. That will give you the derivative plot. Whereas in the semi-log, it is plotted between pressure versus your log of T. T means here delta T. So flowing shut in, the BHP builds up as a function of time, and the rate of pressure buildup is used to estimate the well and the formation properties. So like this again can be divided into different regions. So when you see that there is a lot of gap between your actual and your derivative plot, and this type of thing will be differing from your different type of flow regimes. So from there we can get in the build-up test we can get average drainage area of the well and skin factor in the region immediately adjacent to your wellbore. So when you see the response, this will be the equation of this, and this is derived from your diffusivity equation, which on conserving mass, energy and momentum. Combining all this, will be getting a solution for your diffusivity equation, and this is one of the solution for that. Actually here it will be K upon pi mu C R W square log of, but instead of that we'll try to replace that with your Tp plus delta T upon delta T. So wherever you have this term, we'll simply replace with this T plus delta T upon delta T. Next, what is the drawdown testing? I think in the previous only I told about what is the drawdown testing. So this drawdown testing is done at a flowing condition. At what flowing condition? Constant terminal rate. At a constant terminal rate, we will be observing what is the flowing condition through your pressure response. The pressure drawdown test is conducted by producing a well, starting ideally with a uniform pressure in the reservoir. Rate and pressure are recorded as a function of time. So Q and P are measured with respect to your time. What is the objective is like you can get permeability. Of course, in the previous case of your build-up test also we can get permeability. Even from this also we can get permeability. But regarding the skin factor, there are most of the things you can get easily for the skin factor. So what are these these wells are particularly applicable for when you are having a initial new wells. There is new wells. Next one, wells have been shut in sufficiently long to pressure stabilize. Because what is the difference between the build-up because in pressure build-up we are able to shorten the well for only a small time, but in the case of your pressure drawdown the time period will be larger. So obviously we'll have a more room for pressure stabilization, but whereas in the pressure buildup you don't have such case. So third one, wells in which loss of revenue incurred in the buildup test would be difficult to accept because the well has been shut down for a long period of time. I mean long means in terms of days, like 72 hours. Depending on our duration, sometimes we'll do for 72 hours or more because arranging that setup is a very difficult task. That will be like in well test operation, you will learn about that. And the response of the pressure flowing rate will be like this. And this is similar to the one earlier we have seen. But in the earlier case, this was transformed into Tp upon Tp plus delta T upon delta T in the case of the previous one. But here we have left the same thing as it is. So what is the two rate flow test? So up to this time, it will be declining in certain order. After that, it may change the path. The deviation will be slightly changed. So why I am every time drawing this with respect to this? Because applying the rate only, we are getting the pressure response. First we are applying the rate. According to that, we are getting the response of that pressure response. So this is the condition. So this was initially at Q1, but after certain period of time T1, it was changed to the new flow rate, that is the Q2. So here what was obtained is, we applied the principle of the previous equation. So two rate, when we have a changing, two rate test can be used when estimates of permeability, skin factor or reservoir pressure are needed. So during that time, we'll use a two flow rate test will be used. Next, the next is a two rate test. We need to validate it, and we must maintain a strictly constant. So why I have written the two equations in this is, initially this was written only in this term, but since we are talking about a limited time period where you will have this, so that time should be transformed into this, and this is an approximation. So you have a flow rate 1, Q1 and Q2. So up to here it will be in Q1 and this will be Q2. So the difference between this is Q1 minus Q2. So accordingly that was divided and you got this time T1 corresponding to that. So again here also we can get your permeability, skin factor is common, but reservoir pressure, I mean you can get other conditions of your what you call it, average reservoir pressure, you can get it from the previous one. But here, like when you add more and more wells, I mean different flow rates are changed. Obviously this two flow rate test is used. Similarly there is a n flow rate test is there. The same thing equation, but we are written for the n number of terms. So when you extend the two flow rate for a n and n rates, obviously this will give you the n rate flow test. Again in all these cases, if you observe, we are doing it constant rate. So this is what I told about the flow after test. So a well flow is selected at a constant rate until pressure stabilizes to a pseudo steady state is reached. So initially it was maintained at a Q1 and after that flow rate is increased. So correspondingly there is a change in the flow rate, I mean what I call pressure. After the change in the Q3, again the pressure is changed, so on. So when you plot it, we have to see what is the corresponding impact on your pressure. So here, why you are seeing a spike in this? Because here the well is shut. The stabilizer rate and the pressure are recorded and the rate is unchanged on well flow until the pressure stabilizes again to a new rate. So this is done for n number of times, even though I have shown only for a few, but it can be done for a n number of cases. So what equations which are using in the after flow test are your QG. So n is your exponent, like taking the logarithm on both sides, we'll be getting a plot of log plot. So from where we can get the QG value and the C value. Similarly, We can also take the other graph, which is talking about P square, P average square minus a PW square divided by QG, and this was taken with respect to your time. So this is about the flow after test. Obviously, this is for your gas wells only. We can't use it for oil wells. So the objective of isochronal is to obtain data to establish a stabilized delivery rate curve. So if you see that well was produced at a flow rate of a Q1, then it was shut in. So because of the shut in, there is a rise in this. Again, it was produced at a constant rate, so it is in a declining. Again, how long you will close? Until it will reach the original pressure, average pressure. So again, same shut in, producing, shut in, producing. So this can be repeated for n number of times. So which will show you that this pressures are regained up to its original condition. That is called your isochronal. So procedure is needed. So we have a low permeability reservoirs. Even though it is a low permeability, gas will diffuse very fast. So that is why initially is your equivalent in this case. So what is a modified is, see if you see here there is a gap. This thing doesn't change. The objective of a modified is to obtain the same data as an isochronal without using sometimes the lengthy shut-in. Here we will take a equal intervals of time. Whereas in the we have to wait till it regains it this pressure. So in the modified isochronal test, shut-in periods of the same duration, as I told that this delta T is equal to this delta T, this so on, are used, and the final shut-in before beginning of the new flow period, that will be used as an approximation for your average pressure. Whatever you will be getting the final one, that will be considered as your average pressure. Whereas in the previous one, both are same. Now injection well test, injection test. So if you observe that this is at, we are shutting in initially, but you may have a question that, sir, even though it was in shut in, why this response is written like this? Because we are injecting in the opposite direction. So at that time no flow will be there. Then we'll start injecting it. So that is why this is, the graph is below, rather than in the previous cases it is above, because it is a injection which is a negative Q, whereas in the previous one it is a positive Q. So injection wells may be of a numerous as the producing wells. So consequently, injection wells is important for efficient planning and operation of your secondary and tertiary. So particularly when you are talking about a EOR or any type of injection well, gas injection or other types, then we can use this type of well testing. So satisfactory injection performance. So we can take as over a long period of time and prompt the detection of increasing the wellbore storage, wellbore damage. So here also we see that the pressure is there. Up to here less is there. After that it is going to rise. because we are adding fluid to your existing one. Next, so injectivity and fall of testing in a liquid field. So here we have two cases, one with a mobility ratio equal to 1 or near to 1. The other one is a non-unity, it is less than 1. So in the case of unity, we can go with this. But in the case of negative, we have two different models. Hagsbrook. So in which you'll have a oil bank and other what do you call it, water bank. All these are present in the same, which will try to push it, which is present in your reservoir. So that type of condition is called, this is a simple case, and this one is called composite case. So fall off is like a build-up test. As I told earlier, like it is analogous to your build-up test. But what is the difference is like instead of having a production Q, you will have a negative Q in your, so that is why you are having a injection and shut-in. So for that we are having a response. So an idealized fall-off test is conducted by injecting at a constant rate before the shutting time is Tp. So this, so we are injecting at a constant rate up to the time T. After that we'll close the. So for that, what your response you will be getting? That is nothing but you are indicating the fall off test. Pressure data taken immediately before and during the shut-in period are analyzed and the method developed for the pressure build-up test. Here the pressure build-up test means like a fall off. So next one, interference. So if you see that there are two wells in this, we are marking the response of one over the other. So interference test is a solution for unsteady state pressure change with the time at a given point reservoir caused by the change in flow rate at another point. So you have one well here, other well here. So because of the pressure pulse, you will have some response. Of course, some time lag will be there, but obviously there is some effect. That is nothing but this trend. So now, what is the difference between the interference test and pulse test? Interference test is done only for once, but whereas the pulse testing is done repeatedly. An interference test in which the flow rate at an active well is changed several times in the form of a series of alternative flow and shut-in period instead of producing the well at a single constant rate. So that is called a pulse test. So here you see that the TL lag, and after that you are having a peak 1 and peak 2. So what you will do is in this case, when you plot it, we plot a line where we'll plot the graph, and with respect to that we'll have a draw two parallel lines with extreme end. So this is also one type of time period that is also considered. And see here, the start of the pulse is started here. Up to here it is producing, and suddenly it was shut in. So because of that, you see that there is an increase in the rate. So after that it was maintained again back to your constant rate. Again it was shut in. So how long it is? Cycle 1, 2, 1, 3, 5, 6, so on. So using this will give you your response for your pulse. So this test is done to know the effect of one production on the other one. Obviously, you have in such conditions, within your time of your life of the reservoir, you will have such conditions during which we need to have it. So importance of the well test at the different stages in the field development. So to find out whether the well is a dry well, dry or producing, we have a test called DST. Similarly, exploration wells are done after the DST test to know about the sample fluid, and from where you need to record what is the pressure from the test. Next one, the injectivity and fall-off test. They both are having the same. So this is during your EOR or any recovery. During your recovery, it may be secondary or tertiary, during which we'll be having this type of tests which are done. Next is the interference test. As you develop more and more wells, produce more and more wells, the number of wells are added into the reservoir is increasing. So we need to check what is the influence of one well on the impact of change in flow rate on the other well. Next. So this well test is like a very key role in different aspects, like during your exploration, appraisal, or during the characterization or production engineering. In different points, this well test data interpretation is needed. So first of that kind is your exploration and appraisal one. So the information gained through the well testing will be instrumental in making the major investment decision. Obviously, depending on the sample quality, we'll get a PVT analysis of that, and we can also estimate what is the reserves for that. So using this, we can select that whether we need to go for building a pipeline or develop a field or anything, which is a long-term contract. So what are the two important questions we need to answer for the wells is, as I told, how much is the reserves. To estimate the reserves, we need to know how much is the oil actually in place or gas actually in place, and what is the rate at the wells can produce. So this is like from the point of view of reserves. So for that, what do you do? Flow test often used. They are designed for reservoir to check the economic, because as it is involved with the major decisions are made, obviously economic viability should also be looked into our picture. Next. So distance between the boundaries, reservoir pore volume, and estimation of oil and gas in place can be done from your pressure response, because we need information regarding the saturations, or pressures to estimate the reserves, and formation volume factor is also required. What is a BO and what is a BG and what is the estimated. Next, coming to your reservoir engineering, what is the at that time what is the permeability? Permeability, here we are talking about the effective permeability. What are the nature of and the distance to the reservoir boundaries? Nature means like what type of flow we are observing, and is it like a type of oil? What type of oil? Is it like volatile or condensate or dry gas or wet gas? All these can be found out. Next, what is the average reservoir pressure? Of course, average reservoir pressure I've already told in your build-up test. We'll get the average reservoir pressure as well as the area. So using that, we can get, you can use that average reservoir pressure in your reservoir engineering. Next, what is the importance in your well test? Well test on your simulation. So the knowledge of in situ permeability, as it is reflecting your simulation. So production is also required, forecasting. What is the nature? Even distance of the reservoir boundaries, because in reservoir model, we'll be dealing with the grid system. So when you are marking the same boundaries, we have to mark according to your grid system. So this is important in your reservoir simulation, because spacing is also one study we can do it, because how much space should be maintained between the different wells. We don't want to waste the money unnecessarily by placing the well near to near. So average reservoir pressure is used in reservoir simulation, of course, optimization and your production and material balance calculation. Next, the focus in production engineering is on individual wells. Of course, here we will be talking about the well bore performance. Right, and your IPR. So during this, we require some form of what is the skin factor, what is the permeability, what is the average reservoir pressure or initial pressure. All this we need it in your production from an individual well point of view. So we can also get regarding the well damaged from your skin factor. If the skin factor is a positive, is damaged. If it is negative, improve. So this also can like how about the treatment, fracture treatment or your acid cleaning? After that also we can do, before we already have a before test results, and after doing the cleaning purpose we can observe what is the improvement. So last but not the least is your reservoir characterization, because low permeability or low reservoir pressure is unable to produce, it is not going to give you the good performance, so which resulted in a poor well performance. A nearby invasion condition, like there's some thick blockage is there around your wellbore area, near wellbore area. So which will result in a production is declined because of the mud filtrate invasion, or it may be any other damage because of production fluid or anything. What is the non-Darcy flow or a plugged perforation? So non-Darcy flow will be observed in particularly for the gas flow. During the gas flow, we will be having one turbulent factor, which is very important in determining the reservoir characterization. So you may have only one of this, two, or all the three can have in a same well. So well test interpretation can help identify the cause of poor well performance, so that we can take an immediate action, like as I told, like acid treatment or treatment cleaning. We can do that using this reservoir characterization. Hello?
Yes, sir.
That's all my presentation. So what we learned is, we learned regarding the So are you able to identify what is the list of major types of well test? We have seen like build-up of pressure drawdown, multi-rate testing, multi-well testing, injection well test, so on. List of major tasks of well test interpretation. I think we have seen a procedure like gathering the data and filtering the data. So coming to this three class of well test interpretation, like we have seen like the graph, semi-log, and a derivative, and also like a simulation and history matching. Using that is nothing but the three class of well test interpretation. So define and give a typical values. Of course, we have seen the variables of permeability, skin factor, average reservoir pressure, drainage area, and anything else? Skin factor, okay, fracture length. All these are the parameters which are affecting variables. Next, identify the well test. You know what is a well test, like when you will apply the buildup and when you will have a drawdown. Because if you, build-up test is very costly because you have to close the well. So sometimes we will prefer to go for the drawdown. On the other hand, the drawdown tests are not much reliable, but build-up test is more reliable. So coming to your third part, we have seen that what is the importance of the well test, like whether you talk in terms of reservoir engineering or exploration or appraisal or production engineering. And reservoir characterization. So how it is the decision of your well test are affecting these areas. And before closing the lecture, I'll say that irrespective of the well test or anything, the only thing is we have flow rate, pressure as a function of time. how intelligently you are able to get that parameters by using different graphical approach will give you the desired results. Okay. And thank you for all being patient and listening to the till the end of the lecture. And the session is open for questions.
Thank you, sir.
I hope I try to fill the gap and well testing to certain extent, not fully, but because a 2-hour session for a well testing interpretation is not easy job. I have to go in a very fast track to cover so many things. Okay.
Okay, sir. So we can take the Q&A first.
Okay.
So first question from Elijah. So what is an in situ permeability?
In situ means at time, the real time data, whatever we are getting, right? Using that real time data means at that point of time. See, generally when you take any log, you will be taking the log at the surface and then we'll be observing the values. But here, what we are doing is in situ means at that point of time, what is the permeability?
Okay, sir. Next question.
Okay.
So which is the best well types in terms of getting the accurate reservoir parameters in terms of our cost and time taken to carry out the test?
Okay, very good question. See, anything which is related to the cost is like we are shutting the well means definitely it will cost you some money. If by closing for certain period, it may be like generally will take for 3 days. 3 days means like 72 hours. 24 hours into 3 like 72 hours. So we are wasting the money for 3 days and for getting a very crucial information. And why you are, in terms of cost is very important because you have to arrange the equipment, you have to lower the equipment from where we will be recording this, and we have to pull it to the surface. So this will take around 3 days. But regarding there is no single answer which is the best well test, because not all the well test will give you all the information. Like we for certain information like regarding the EOR, as I told that injection well testing is needed. Depending on the stage of development in the well, we'll use the different well test.
Okay, sir. I think there are no more questions. Participant, if you have any question, you can just drop in the chat box.
For isochronal test, when you shut in the well, why is the pressure returning is to original pressure? See, actually theoretically it works, but in practical sense it is not possible. That is why there is a alternative for that isochronal. That is a modified isochronal test was existing. We can't reach it. Technically, it is very difficult to reach to the original condition. That too, it is only possible with the gas. If it is like oil, it is there is no way.
Okay, sir. Next question. How accurate is pressure transient analysis using surface-based acoustic field level, surface and casing pressure measurement?
See, we always store the information like accuracy is like it all depends upon the flow rate record. If the flow rate record is accurate, obviously our results are accurate. If the flow rate, whatever you are recording is not accurate, obviously it will affect our quality of accuracy. And what is that analysis using the surface based acoustic fluid level? I think in certain cases, if you directly place the recorder at the against your well bore, that will be better instead of certain times you will be doing it from the surface, but some disturbance will be there if you are using that acoustic fluid level survey because of vibration or anything, or because of the flow also you may have some disturbance.
Okay, sir. Participant, you can just drop your question, and if you want, I can unmute yourself. Just you can raise your hand if you have any question in your mind. Okay, I think no more question. Okay, one more question get found.
Yeah,
Sir, is it
it's
possible to do drilling and will test together?
say maybe you have to start. It is very difficult doing drilling and doing getting the well test together because well test is maintain the flow rate, right? And drilling is done at the initial stage of your exploration. Means just to connect the reservoir to the your production, we are doing the drilling. But I don't know why you ask like well test together. Generally, like not well test is possible, but DST is possible. Drill stem testing is possible. Drill stem test is to test whether the well is a dry well or a what do you call it, producing well. Is there any software for well testing? Of course, there are softwares. Kappa is there. Kappa's Sapphire is there, particularly for the transient. And Weatherford is also having now. I think previously they used to have a PAN system, but now it was taken over by the Weatherford. And the Feteki is one, um, which is also have a well test. Who is
Okay.
this? Please display the slide, each one again. Okay. This one?
Sir, let's take the next question. So, can we determine well test interpretation if the formation has sand issues?
Yeah. Could you repeat it again?
Yes, sir. Can we
Yeah.
determine the well test interpretation if the formation has sand issues?
Sand issues because you cannot do because first we need to because sand production is we can't do it properly. We can't get the reliable data because sand production obviously it will interrupt our data and it will corrupt our readings. So I think we have a completion job like gravel packing or some sand screens should be placed. We may try, but we have to take some alternative. First, we need to isolate that. Then we can do the well test.
Thank you, sir. I think no more questions from the participant. And guys, if you have any question, you can just drop in the WhatsApp group or you can just drop me personally. So finally, thank you so much, sir, and thank you so much, participant, for joining with us in this wonderful session. Hope you have learned something extra from your co-curricular classes. So without wasting time, I would like to thank especially Anuprakash sir for your wonderful and precious presentation, sir. Really, we learned a lot of things. And
I will plan for one better session if like a complete a full length session in future, but it all depends upon the how many people are interested in that.
sure, sir, we can, sir. And participant also I want to tell that if we are also conducting software that is Kappa in future. So if you are interested, you can also drop me. You can join that Kappa session. So thank you so much, sir, and thank you so much, participant from the team of Petroleum Engineers Association.
Okay, thank you very much, Nikhil and Petroleum Engineering Association and all the participants. But you have taken a pain for sitting and looking at my boring lecture. I think I tried to make my presentation as simple. I didn't go in depth. I thought like a 2 hour session will, if you go in depth, it will be very difficult to understand. So
No, sir,
that's
but
all. Thank
whatever
you,
we
sir.
have talked, so thank you,
Yes.
sir, so much, sir.
Okay.
Thank you so much, participant. Have a good day, ahead, everyone.
I think one more chart. Okay. Okay. Okay, Nikhil.
Okay, sir. Okay, sir. Have a good day, everyone. Good night. Take care.